Hello, everyone. Welcome to the second lecture on Polkadot SDK. Very excited to have Cisco today with us. He is also a PBA alum and a core Rust engineer at Parity. So I'll let Cisco take over, and if you can introduce yourself, Cisco, and start your presentation. Thank you.
Yes, so thank you, Kadeja. Hi, everyone. Today I'll be talking to you about Polkadot SDK, a little bit of an overview. I am in the Discord and I have talked a little bit already, so of course I'm gonna answer questions during the course of this lecture, but if you have any extra questions or want to chat about anything, I'll be there. So first, a little bit about myself. I started this journey into Web3 by going to the first Polkadot Blockchain Academy. It was on-site in Cambridge for 1 month. And that was in the summer of 2022, I believe. So I've been here for like 2.5 years at this point in Polkadot. I started there and I've been there ever since. After the PBA, I joined Parity Technologies. Not immediately, but I was learning more about things and I ended up joining Parity Technologies as a Rust developer in XCM specifically. And I was doing Web 2 before. When I went to the academy, I just wanted to do Rust pretty much. I didn't know much about blockchain, just some vague concept of Bitcoin and Ethereum. And someone sent me the Polkadot.network website because they knew I wanted to do stuff with Rust. They wanted to do something with blockchain. I subscribed to the newsletter and eventually got an email saying if I wanted to go to the first blockchain academy. For some reason, I agreed and didn't think it was a scam to be like paid to go and learn about blockchain in Cambridge for a month. And good thing that I did, because I am now working at Parity. I'm now talking to all of you guys, and I'm a rank 1 in the Polkadot Fellowship, which we can talk about it a little bit more if you want, either here or through chat. And then in my free time, whatever free time I manage to have now, which is the third icon on this slide, we assembled a little team inside Parity to work on Jam, and we call ourselves Jam Brains, and we're trying to do a Jam implementation, which also, if you don't know what it is, we can talk more about it later as well. Now I want to share with you a little snippet for the whole presentation to give you a little bit of a teaser. The audio will probably not work, but there are captions on, so you'll be able to at least hear what is being said. And this is taken from the Web3 Summit in Berlin in, I think, 2018. So I'll just show you the video now. Good, so what we saw is this presentation that Gavin Wood, the co-founder of Ethereum and founder of Polkadot, did a lot of years ago at this point, where he wanted to show how easy it is to build your own blockchain using this framework that I'm going to be talking about today, and you have been learning about this week or these weeks, which is called Substrate / Polkadot SDK. And he wanted to show just how easy it is to actually create your own blockchain, which is something that sounds very hard. So what is it? Polkadot SDK then is a modular Rust framework for building blockchains. So you can think of the SDK or of Substrate as a tool to build blockchains. You have SDKs for building mobile applications or websites. This is a tool that if you want to build a blockchain for any reason, you have a use case that needs a blockchain, you can use this to build one. A very good benefit that it has, I told you that this video was from years ago. It's a very battle-tested framework. So it has been tried in multiple things, multiple different projects. We at Polkadot, we have a system where everyone can create their parachain or rollup, if you are more familiar with that terminology, and benefit from the whole of the Polkadot ecosystem. So we have seen a lot of parachains, a lot of rollups being built with this SDK. We have seen solo chains, so just chains not even connected to Polkadot built with this SDK. And then tons of dApps built that interact with those chains. So if you want to build a blockchain, it's really a very good tool. It's battle tested. Many projects have used it, and it's very simple to use, fun. If you agree with that or not, it's a very good tool overall. And you have a community, you can ask questions and so on. So what are the key sort of design decisions of the SDK? It's flexible, fast, interoperable, and future-proof. Those are the pillars that I will be talking about. So first, flexible. We don't want to force anyone into doing just one specific thing. We want to give the developers using the SDK as much flexibility as they want. So of course, if you want more flexibility, it's going to be harder. You're going to need to take a lot more decisions, have a lot more opinions, do a lot more work building all the things you want in order to have that flexibility, but you can do it. And then on the other end of the spectrum, you can just use something that works out of the box if you don't want that flexibility. But we give you that flexibility to actually choose your path and do whatever it is you need to do. Then it's fast in the computer program sense, like the underlying or the output of building your blockchain. So the executable itself is going to be fast. This is a Rust framework, and we have done a lot of complicated optimizations and so on, so that the people that use this SDK can have a very fast executable at the end of the day. So can have a fast blockchain, which fast also means cheaper to run and more and greener, more environmentally friendly, because you waste less time doing useless things. It's also interoperable in various senses of the word. So we built this SDK so that people can create not only blockchains, but also it's easy to create small modules of logic that can then be used by other people, can then be shared and used by other people. So it's interoperable in that sense of the word. And then we've done a lot of work on top of the SDK to be able to interoperate between multiple chains, so send messages across chains. And this SDK makes it easy or enables you to use these features, for example, connected to Polkadot, and then you can send messages to all of the connected networks or via bridges and so on. And then it's future-proof. This is one of the, I think, most exciting things about the SDK, which is that it has been designed in a way, which we'll talk about in the future slides, to be upgradable. And that's also something that if you want the talk from which I took the clip out of, where Gavin talks about like creates a blockchain from scratch. He also upgrades the blockchain, like deploys it, makes a little change, and upgrades it. And this upgradability of blockchains is something that not many other blockchains have, or blockchain frameworks have out of the box. Usually when they need to update, they need to think it through a lot, have a good period where they make sure everything is fine, because it's very hard to go back. And then they release a new executable and convince everyone running the software that they need to update, which might result in a hard fork where some people update and some people don't. This framework offers upgradability out of the box. That makes it very easy to treat it as a normal just software where you can update it on the fly. This framework, and here I use the word Substrate because you will see it around a lot. Substrate was the original name, and then we decided to change it to Polkadot SDK because we added more things to it. But this framework is so like flexible and generic and useful that it was actually used to build Polkadot. So Polkadot is a blockchain network. It's an ecosystem of blockchains, all built with the Polkadot SDK or with Substrate. And really, Polkadot embodies this idea of a multi-chain future. And we couldn't really have a multi-chain future if it's so hard to create a blockchain in the first place. So this SDK is really at the heart, among with other things. This SDK plays a crucial part in the multi-chain future, allowing everyone to very easily build blockchains to then, for example, use in Polkadot or in other places. So then why am I talking about the Polkadot SDK and then mentioning Substrate? Because we did a move, so Parity Technologies, the maintainers of the SDK, they moved from a lot of different repos into a mono repo a long time ago at this point, some years ago. And with that move, we decided to rename all of these different components as Polkadot SDK. So now the Polkadot SDK includes things like Substrate, which is this framework that I was telling you about, Frame, which is this little opinionated framework on top of Substrate, and then stuff like Cumulus, Polkadot itself, and then XEM, which we can talk about all of this in turn. But I want to get to the more interesting part of the framework, which is basically this upgradability that you get. So the biggest opinion that Substrate makes, or that the SDK makes, is this division of the blockchain into two parts. And here we see a diagram where we see these two parts. One we call the runtime, and one we call the host. So when you build a blockchain using this framework, you do not build like a monolithic thing, like just one huge chunk of code that does everything it needs to do. For example, connect to the network, import blocks from other peers, gossip blocks to other peers, and so on. And then having a database, but then also having the concept of a cryptocurrency or of governance, and so on. So instead of creating a monolithic structure, with this framework, you have a separation between the host, which is meant to have things like networking, telemetry, the database, the transaction pool. It works in a multi-threaded environment. It's like sort of the infrastructure for your logic, right? It's all the things that every blockchain pretty much needs. And then the runtime, which is meant to host all the actual business logic of your chain. So this is what is different on each blockchain. So the host is either the same or very, very similar in most blockchains. Like they all need to do some type of networking, have some type of database. They might have some changes, but it's pretty much very standard. or it changes very little. And then the runtime is the actual business logic of your chain. So in the runtime, you can define things like the cryptocurrency or referenda, where you vote on referenda, or some identity primitives, or whatever might be special for your blockchain, or whatever, for example, goes into your transactions, right? So you have these two parts, host and runtime. And this is very cool because now if you don't want to deal with networking or database or so on, then you can use a pre-built host and you can just focus on your business logic. So now you don't need to worry about making your database from scratch or your networking or your consensus algorithm. You can just use the ones that are provided and then just work on your runtime, which is much easier to reason about. So here's this flexibility that we talked about. Because if you want to change the host, you can, by all means, you can, but it's going to be harder because you are going to have to deal with these things. But if you just want to build a blockchain so that you can create your token or experiment, or yeah, you just want to create your blockchain for the logic itself and not because of the underlying like infrastructure things, then you work on the runtime. The interesting thing, so this is already nice because it gives you this flexibility of only working on the runtime if you want to. But then there's this other aspect to it, where the runtime is built in WASM and the host is in Rust. So the host is in Rust and is a normal binary that executes on your machine. But the runtime is compiled, it's also written in Rust, but it's compiled to WebAssembly. WebAssembly is this format that you can use. That is being used in the web and in other places. It's a virtual machine. So lots of environments can execute this virtual machine. So in this case, we compile it to this virtual machine code. And why do we do this? So that we can store the code in the database of the host. So all of the business logic of your chain lives in the database of your chain. And this gives you the upgradability that we mentioned before. This means that whenever you want to upgrade and you want to submit a new code, a new WASM code, a new WASM runtime, you just create a transaction, submit it to the chain. And if it goes through, it just grabs the new code and overwrites the old code. And now everyone at the same time has the new code. So this is a very, in my mind, revolutionary concept that not a lot of blockchains have, which lets you upgrade forklessly. Everyone can just do an upgrade and keep on moving on with their lives. So this is one of the benefits of having this divided approach. It's not the reason why we did this approach of dividing, but it is a very good consequence of it. Then another thing related to interoperability, by having this division, the runtime, we have this framework, which I'll talk about next, where we have these things called palettes. And palettes are modules of functionality. And you see in this diagram, we have, for example, a balances palette, a uniques palette, and some other custom palette. These palettes are the things that people can develop and share with others. And then you assemble your runtime out of all of these building blocks, like they were Legos. So by using this, you can very quickly just import some palettes, put them all together, create the runtime, use a host that already exists, and boom, you have a blockchain. A blockchain that is upgradable, that is fast, and that is very easy to keep on adding things to it. So I can talk about Frame, but I would like to stop for questions here because this is like a big part of what I want to tell you guys, and hopefully convince you that it's a good thing and a useful thing. So I would like to know if you have any questions about this. And I will also look at the chat in case there are any questions. At any point, feel free to just send some questions to the chat. I will do some of these pauses to just talk about them. Someone asks, what if someone has a front end where they promised people that it's connect to the blockchain, but it's actually not? And then I think it continues how to prove or avoid scams where the front end promises that I talk to a smart contract, but it's fake talk to an API. Yeah, and then they ask the same. They continued again. Okay. Yeah, so this is about like the dApps that you can build on top of this, like the interfaces that interact with the chain. It's a very interesting question and very relevant. We solve this by, for example, if you're using a wallet, it could be like a browser extension or a hardware wallet. You will need to sign stuff on your wallet, which is a different application from the UI that you're interacting with. So you will know what you're signing and to where you're connected. So even if the interface wants you to believe that you're interacting with the blockchain and you're not, then your wallet will let you know that you're not interacting with the chain, for example. At the end of the day, like, you still need to sign something. There's this issue called blind signing that you might have heard about if you follow the news, the crypto news, that a lot of money was lost because a company signed something blindly. In the Polkadot ecosystem, we have very good human readable transactions that are showed even by hardware wallets. So you can know what you're actually signing every time you need to sign it. So I would say it's less of a concern here. Another thing we have that kind of escapes this talk, but it's very cool to mention, is that with this framework, you get something that is very light client friendly. And light clients are something that maybe you already learned about or you will learn about after. But light clients are so light, like they're nodes, they're hosts, kind of like blockchain nodes that are so easy to run that you can run them in your own computer all the time. You can even run them on your mobile phone. And these nodes are part of the blockchain network. So they will take part in the blockchain network. They will import blocks. They will gossip other blocks, and they are able to ask their peers for stuff and ask for cryptographic proofs of things. So here it's so much easier to not be scammed, like to not be lied to, because your computer is already running the program that takes part in this whole network and will ask for cryptographic proofs for things. So on one hand, you have this signing thing, and on the other hand, if you want to ask for data, they cannot lie to you because you can check the cryptographic proofs. And that's very nice and all. And if you use this framework, you will get this pretty much out of the box, which is very, very nice. I can't overstate how useful light clients are. They really embody the Web3 philosophy of not needing to trust central entities. It's this less blind trust, more verifiable truth. And then one more question. So when I upgrade blockchain, people can have the option to stay in the old one and move with my new fork. This is a very good question because I wanted to make sure that this was understood because it's kind of hard to wrap your head around. But because the runtime of your blockchain is in your blockchain, whenever there's a transaction that changes it, which of course needs to be permissioned or whatever, right? Like you don't want anyone to upgrade your chain code all the time. It could be via governance, for example. We all make a referendum. And if the majority of people agree, then we change the code. We change the runtime. And by doing that, automatically everyone will have the new runtime, the new code. So this would be forkless. So you don't need to choose, like to make a decision to choose to go on with the new code or go on with the old code. If you are following the protocol, and if, for example, there was a referendum and the majority of people wanted the change will happen. It will be self-enacting. It will happen on chain, and then everyone that follows the protocol will follow the new code. Of course, you can always do a hard fork if you disagree with everyone else, and then you go on your side. Like that's always allowed. But then you are like you're left alone and you don't follow everyone else. But these forkless upgrades are a very good feature of this framework. Okay, I see there are no more questions for now. You can, of course, while you keep on thinking about this, have more questions. So I will answer them later when I see them. Let's move on. So the main thing that I want you to get out of this diagram, that again I talked for a long while and it's very complicated. The main thing that I want you to understand is there's a division between the host and the runtime, and the runtime lives on chain, so it can be changed via a transaction. And then that's it. That's basically substrate. Like that's basically the Polkadot SDK. And then how you build this runtime is actually up to you. And we offer a framework called Frame, which I'll talk about next, which makes it very easy to build these runtimes. But you could build this, so Substrate doesn't tell you you need to use Frame, doesn't tell you how to build this WASM runtime. It only tells you that you need to satisfy a few interfaces, right? Like any normal piece of code. So let's talk about Frame. So what is Frame? Frame is a framework for building substrate-based runtimes. So there could be others. I mentioned in the chat yesterday that there is another one called Tuxedo, which you can try to use. You can create your own, or you can just go without a framework and just try to build a runtime on your own. But Frame is like the most widely used one. It's very useful, very flexible as well. And I think you'll like it. So Frame is based on this notion of palettes. Why we call it palettes? It might be because they are like, because you have a frame where you're painting and the palettes are the things you use to paint on the frame. It might also be called a palette because palettes and crates are kind of used together. But regardless of the name, palettes are just modules of logic. And so we assemble the runtime from little modules, like little Lego blocks. And each of these Lego blocks can do different things. This that I'm showing right now on the screen is the structure of one of these Lego blocks. So every palette has some configuration, so you can change it. Like I can use the same palette as you, but we can configure it in different ways, and then they're very different. And they are like, they are fitted to our use cases. Then they have some hooks. The hooks are things you can do before a block or at the beginning of a block, at the end of a block. Those types of life cycle hooks that if you have made some programming in the past, you can be maybe used to them having some life cycle hooks when you destroy something, when you create it. In this case, it's like at the beginning of the block, at the end of the block. Then it has some calls. Calls are the actual things users can call from the outside world, from like outside of the blockchain. It has some storage, some things that they can store, right? Like balances, for example, like NFTs, like whatever else you might want, a counter. Then it has events to let these interfaces subscribe to events and know when stuff happened, when stuff changed. And it has errors, so to also notify the user when things go wrong. So these are all the building blocks of a palette, and if you're familiar with smart contracts, they look pretty much the same way, right? They're like everything that a single module of logic looks reasonable that it has. The difference with smart contracts in this case would be maybe the hooks and the config, since you can configure it for different use cases. Now, what palettes are there? So now we take a step back. We talked about what a palette is. And now, what palettes are there? So we have built, and the community has built, some palettes that they are like they're like independent, and different teams can choose to use them, right? Use them as they come. They configure them and they use them. So for example, we have a balances palette that lets you have a cryptocurrency. We have NFTs palette that lets you create NFTs, which can be useful for certificates, for works of art, for books, for whatever. Then we have the assets palette, which lets you handle a lot of different assets. The asset conversion palette that lets you do swaps between two chains, referenda for voting, conviction voting for voting as well. Referenda would create the proposals. Conviction voting will let you vote on them in a particular way. We have a salary palette for automatically paying salaries to people on chain. We have the ranked collectives. We have contracts, so you can create your own chain and put smart contracts on your chain. And we have so many more. But these ones are some to like give you some ideas of what is available. So again, these things are reusable modules of logic that if you are just starting, if you want to create your blockchain, you can reuse this. So you can very easily create your own blockchain that has, for example, a cryptocurrency, NFTs, voting, swaps, smart contracts, salaries, like all of these things. And that is very, very powerful. So here I am highlighting some of the options. So you can build a chain that has balances, only balances. You can, with referenda and conviction voting, have a very nice decentralized governance. With salary and ranked collective, you can have on-chain organizations earning salaries, like in Polkadot, the Polkadot Technical Fellowship, for example, fully on-chain. And then we have so many more, like you can have multisigs, proxies, some recovery mechanisms in case users lose their wallet. We have things compatible with EVM. We have this XEM stuff, which is for sending messages between chains. We could have a treasury, which is this pot of money that we all contribute to, and we can decide how to use it. Staking, a lottery, a lot of things. And even more than here in this slide. So whenever you use this framework, you have access to this pool of lots of cool and audited, so secure pieces of functionality that you can use on your chain and to just get started. Good. I will pause for a while to drink a little bit and see if anyone has questions about Frame. Good. Let's keep on going. So this is sort of like an overview. So I'm not gonna tell you how to like program a palette, but that will be something that if you want to program a palette, you can. Also, if you don't want to program a palette, you can still program a chain by just picking and choosing all the palettes you want. That's like the main idea that I want you to take from this frame section. So from the substrate section, I want you to understand that when you use this framework, there's a division between the host and the runtime. And then from this frame section, I want you to take that this frame thing can be used to build runtimes in a way that you're basically using like different Lego bricks, and you can pick and choose whichever you want and only build one if you need something custom or if you need some functionality that doesn't exist yet. So with that little conclusion for this section, we can continue. So what about interoperability? What does this framework offer in terms of interoperability? And what do I mean by that? So on one hand, you can create and share different palettes and people can use them. That's very nice. Also, different chains built with this framework expose a similar API for front-end libraries to consume. So if you can make an interface, like a UI, a DApp, that can connect to any substrate-based chain or any Polkadot SDK-based chain. And that's something we do a lot. Like you will see that it's very common to create a DApp that works with any chain, or at least is able to recognize any chain and maybe pick and choose what features it wants from each chain. And that's very interoperable. But another thing is how can we have chains call each other? That's a very interesting topic. So on that front, we offer two things with different levels of integration, like of how easy it is to integrate them on your chain if you want to go and build a chain tomorrow. We have built trustless bridges using this framework, which means that if you use this framework, it's not hard to integrate these trustless bridges. I mean, I think right now the documentation might not be the easiest because again, it's a complicated protocol to actually be able to communicate with another blockchain. But it is there and we want to improve it and we are constantly improving it. So you have access to this even more than if you were to use another framework or to build your blockchain from scratch, right? And then we have this thing called XCM, which is a language, an intent language that you use to communicate what you actually want the other chain to do. So on one side, we have how do we send a message from A to B? And on the other hand, we have, okay, what do I actually say in that message? And we write these messages in XCM, which is this language, to express things like, hey, can you please transfer this money, swap it, and execute this smart contract, for example, right? So XCM also is very integrated into this framework and you can use it. It's an agnostic language. It could be used anywhere. But if you use this framework, it's like our opinion on how cross-chain communication should be. And of course, you can use whatever you want, but this comes from for free and has a nice community. Everyone uses it. So it's very useful to have it. It gets you started easier. So let's talk a little bit about the bridges. So the bridges are how can you send messages from A to B? A to B being blockchain systems, right? The blockchains. So what a trustless bridge is a bunch of off-chain relayers. So when I say off-chain, I mean random people around the world that are not taking part. So random computers around the world that are not taking part of this consensus. They're not dealing with blocks and so on. They are just a regular computer program, relayers, running on some program in some user's basement, for example. And their job is to grab messages from A and post them, like submit a transaction on B. That's the way that we can do this communication. But how does B trust the relayer? It doesn't. We require the relayer to submit messages to B along with a lot of cryptographic proofs that B can check to make sure that those messages were legit and they actually came from some other user. And because these relayers are permissionless, anyone can run a relayer at home, then this is a trustless bridge. There's no need to trust any central authority or any group of individuals. Anyone can just run a relayer and they will get paid for it, of course, because they need to maintain a computer, they need to pay for electricity and so on. and they are the ones that are actually doing all these cryptographic proofs and so on. This, of course, always happens in a computer, so it's not a human sending the messages around. It's a computer, so it's a human that runs an executable on their computer, and this executable will always connect to these two chains, submit all the messages, and so on. This is in contrast to something that I think is quite surprising about most bridges out there in the blockchain ecosystem right now that are trusted bridges. So this approach of getting a message from A and posting it on B is pretty much the way you can do communication. But instead of doing it with cryptographic proofs and with permissionless relayers, there are a lot of bridges out there. Like, it's really surprising to see that they just have like a committee of 5 people, like five random people that will do this for you. And of course, that's not very decentralized and not very like in line with the Web3 vision. And it's very insecure because you have now one single point of failure. And if you look at all the hacks that have happened in the last years, most of them have to do with bridges, and most of them have to do with trusted bridges. So it's very good to like have trustless bridges here. It's very good that you have this, or that you are closer to this when you use this framework. Let's keep on talking. So another thing we have for you if you use this framework is this thing called HRMP. It's just a acronym. It means horizontally relay the message passing, which means if you are using Polkadot, because you might choose or not to be part of Polkadot as a parachain, like as a rollup for Polkadot. If you choose to be part of Polkadot, then you get for free without any additional work on your side. You get this communication between parachains. Like, you can communicate between any parachain, and it's very easy, simple, low latency, and you get it for free. So that's one of the benefits, as well as shared security from being part of Polkadot. An XCM is a language for communicating intention between consensus systems. And here, consensus systems is just a fancy way to say blockchains or smart contracts or like anything that lives in this Web3 world, right? So XCM is this language. And why do we have a separate language? Why can't we just post transactions? Basically because different chains might be very different. And we might have a lot of them. We do have a lot of them in the multi-chain ecosystem of Polkadot. And if you bridge to Ethereum, then you have even more, which we do have a bridge. It's called Snowbridge, and it's one of these trustless bridges that I mentioned, and it connects Polkadot and Ethereum. So there are a lot of chains, and if you wanted to interact with chains, then you need to, if you want to interact with chains with their native transaction format, then you need to look into them, each of them in turn, and see what they have and so on. But if we have an intermediary language, we can abstract that away. So here, let's say parachain A, or any type of chain, right, using XCM, wants to send a message to parachain B. If parachain B upgrades, because with this framework you can upgrade, the format might change, and then the message is broken. But if we had this intermediary language based on instructions that specify intention rather than how it's actually implemented on the other chain, then when the chain B updates itself, it can interpret intentions differently, and the same message won't be broken anymore. That's basically why we have XCM. So we can send messages to different chains in a more or less standard way, and even if they upgrade or if they change, they can still interpret as fine. Good. Now, again, I'll make a little pause in case you wanna ask some questions in the chat, and then I will tell you about some developer tools that you can use or can expect in this Polkadot SDK ecosystem. Oh, good. Do let me know if I am speaking too fast. Because I get excited about these things, so maybe I can talk too fast sometimes. I would really like for anyone to send something in the chat so I know that I'm still online. Is everything good? Nice, thanks. Okay, so hopefully all that part on interoperability elucidated some things for you of like how can different chains can talk to each other. Good. There we have a question. Nice. So someone asks, I'm kind of lost here about XEM. If I'm not wrong, XEM connects dot with EVM. How they connect to EVM, which is written in another language from Rust? How does this work? It's a good question, of course, and a relevant one. There's like a lot to unpack there, maybe. So XEM. So in this interoperability part, we talked about two things. One, the how you send a message. So interoperability is based on sending messages. Yeah, like that's the way we like fix interoperability. Let's say we send the messages. So in this slide, we have the how on the left, the trustless bridges. That's like how can we send some bytes from A to B. And then the XEM is the like what, like that those bytes. What do they say? What language do we use for them? And we use XEM. So when we send messages from A to B, if you are on Polkadot, you get this HRMP for free. If not, we have, for example, on Polkadot, a bridge to Ethereum. So that's how we send things from like WASM land, you might think, like things that are built with WASM to things that have EVM, because that was kind of the question. But it's just some bytes, so it doesn't matter the underlying virtual machine, right? It's just some bytes that you send to some other place. And now those bytes are written in this XEM format. Here I don't have an example of how it looks, but yeah, they're just some bytes or some intentions. Yeah, so about the reading the query from the EVM block. So the person asking this is more interested in like the how. I can share later in the chat maybe how the documentation for Snowbridge. Yeah, there's a lot of things going on, but basically the relayers will call something on Ethereum, for example, to actually submit the messages. But then XEM it says things like, for example, withdraw some ETH, right? And maybe swap it for something and then deposit it on some other account, like some intentions on that level. So then if you manage to use the bridge to send this XEM over, and then, for example, call a smart contract, right? So then you send this message over, and then you need someone on the other side to interpret the message. So for the Ethereum case, you would need a smart contract because that's the layer of programmability that Ethereum offers. You would need a smart contract to grab those bytes and interpret them and do what they say. In Snowbridge, they do have like a gateway smart contract that will receive all the messages and interpret them and so on. So hopefully that clarifies how they do it. And it doesn't matter if it's WASM, if it's EVM, you just need some way to interpret this language. And that's also why we have this like abstract language, right? Good. And then we have another question regarding upgradability. So someone asks, what about backwards compatibility? Can't upgrading the blockchain break something in the dApps that are built upon it? And that is correct. Upgrading something can break the dApps that are built on it. However, this is true for other apps that are not like Web3 specific. And it's a huge problem because of course, we would want things to work in the same way forever without breaking. Or not the same way, but we would want things to work without breaking ever. But we also want things to adapt and to like move on and update. So what we have is we have tools that lets you, if you build an app, you can actually check the current runtime. We have a runtime version on chain. And whenever we announce a new runtime, or the developers of the network announce a new runtime, it will be available for everyone before it gets enacted on chain, like before it gets changed. So the dApp developers can just grab the new runtime and check for the differences and check if they need to do anything. Sometimes they don't need to do anything. Sometimes something that they were using was changed. And in that way, they can very easily like add an if statement on their application saying, if you're on this runtime version, do A. If you're on this other runtime version, which will happen in the future, do B. And then without any downtime, they can upgrade whenever the upgrade happens. So we have tools for this. Okay, let me tell you about some tools and some resources where you can investigate and use to learn more. So one of them is this Polkadot API, not to be confused with Polkadot.js, which has a very similar npm package. But Polkadot API is it's a very good front-end library to do these things. It even has examples on how to do this, like, hey, the runtime is changing. How can I update my dApp in real time without needing to do manual intervention? It has a recipe for this. And it's light client first, so you get this nice property of people not being able to lie to you or to censor you, because you run a simple node in your browser itself, in the browser itself. And we have a lot of, this is a very nice tool to build dApps that you can investigate. The website is Papi, so short for Polkadot API, papi.how, but I will share it in the chat later in the Discord. Then there's this thing called Pop. So Pop is also a network, but they have a Pop CLI. So it's a CLI where you can just, if you search for Pop CLI or Polkadot Pop CLI, you will probably find it. And with the Pop CLI, you can do like pop new parachain, and it will like scaffold a new parachain for you, or a solo chain. I think, you might need to look into the documentation of how to do it, but it will help you create something from scratch. You can do pop new palette, and it will scaffold the palette. And then, it's very nice to just be able to use a CLI to install things and create new things. Then there's Paseo, which is the testnet. Paseo is a public testnet that anyone is welcome to join and create projects and so on. And it's up to date with the latest in Polkadot. It might not be the latest and greatest in like experimentation phase. Well, for that, we have like an experimentation testnet that is called the West End. But for regular projects in Paseo, you can use whatever is in production right now, but without wasting money because you're using a testnet token, which is very standard in every blockchain ecosystem. Then we have this tool called Chopsticks, which is very useful, which lets you like fork a live chain locally to test stuff. So this is kind of like your framework to test locally. Yeah, and Pop is for terminals, like a command line application, command line interface. So Chopsticks is very good for testing. If you wanna, someone mentioned in the chat, it's best to have intense testing. Chopsticks is like your end-to-end testing framework. It's very useful. But of course, having lots of unit tests is always also encouraged. Those are some of the main developer tools that you might encounter in your development journey with this framework, and then some resources to learn more. So a resource that I really like that is basically has interviews with many different Polkadot ecosystem agents. It's called the Kusamarian. It's on YouTube as the Kusamarian. You can look it up. It's very good to know what people are doing in the Polkadot ecosystem, but that also means what people are doing with this SDK. Like, for example, it has interviews not only for Polkadot. It had an interview with people from Cardano because they have their Midnight project that is actually using our SDK. So they forked our SDK and they're building on it and using many of their features. So if you learn this SDK, you can interact with many different projects. So Kusamarian, very nice to learn more. There's this, now if you're a developer and you're urging to do something, there's this very nice website called Kudos Portal. I think it's morekudos.com that lists open source good first issues that you can contribute to if you're a developer from all across the Polkadot SDK ecosystem. So Polkadot, the CLI, different parachains, different solo chains. So if you're a developer wanting to learn more, this is, I think, a really great resource. And then if you're a developer who is stuck, we have our own Stack Exchange website. It's substrate.stackexchange.com. And there people ask, hey, how do I do this in this palette? How do I do this in this runtime? Like, there's a good community of people working with this. And then that's everything I had. So thanks for your time. And I think we have a few more minutes for questions if anyone has any.
Okay. Looks like we don't have any more questions. If they have, you're welcome to post your questions in the Discord.
Am I muted?
Can you hear me? Can you hear me?
Yes, we can hear you.
Yeah, just asking Cisco, I think he cannot hear me.
For some reason, I cannot hear Kudeja. Can everyone hear them? No, it might be just me.
It's okay. You can go ahead with the question, maybe. If you...
Yeah, okay, it's just me then. Just keep on talking. There's a new question in the chat, but I can answer it in the Discord. So, or I can try to answer it very quick. So in this case, this message to Ethereum, the Snow Bridge, makes sure that like the Polkadot chain has an on-chain light client following consensus on Ethereum, and that's how they can prove each other's like cryptographic proofs. That's like the short answer. But I will share the Snowbridge docs because it's very interesting how they do it.
Okay. Well, thank you so much, Cisco. Probably you cannot hear me, but I'll just end the session here. Thanks for the engaging session, and thanks everyone who joined. If you want to revisit, the recording will be present in your platform. So you can revisit there, and you can post questions on Discord. Thanks, everyone. Bye.